you start studying statistics, you were forced to study new variables like the mean, the mode, or the median. And you might ask yourself, why do we need more variables than the mean, which is the one you're used to using? When you want to know the median value of the scores in a class, you just calculate the mean. Well, I want to show you in today's video why the mean is not always a good measure of dispersion, or a good measure of how the values are, what different type of values, and if they have a lot of values around the 5 or around the value, or they're very dispersed. Okay, so why do we use the mean, median, and mode, and many others? First of all, just remember how we calculate each of these. The mean is calculated by adding up all the values and dividing them by the number of values that we have. Of course, if there's many, this is multiplied by the frequency. The median is calculated, is the value that leaves the same number of values to the right and to the left of it. So we normally order them from in increasing number, and if it's and then we have to calculate the central value. Okay, and then the mode is the value that has a higher frequency, the one that is repeated the most. Okay, so we're going to look at specific cases. We have a class of students, and we have the scores, and they get. We have 4 students here, and we have they all get a 5. Okay, in an exam. So if we calculate the mean, that's 5 times 4 divided into 4. That's 5. The median, we have the value in the middle. You have to add 5 plus 5 and divide it by 2. That's a 5 again. So that's the median. And the mode is again the 5, because it's the value that is repeated the most. So of course, in this case where everything is 5, the 3 values are the same. Okay. And then we have another class, also 4 students, and they get a 4, 4, 6, and 6. Okay. So if we add this is 20 divided by 4 is 5, so the mean is the same. The median, again we get the value in the middle, and that's 6 and 4 is 10 divided by 2, that's a 5, so again the median is the same. But here the mode changes, because we have 2 values with a frequency of 2, so both are the modes, so we have 4 and 6. Okay. In the last case, in the third case, we have 2 students with a 0, 2 students with a 10. Again, that's the same mean. 20 divided by 4 is 5. The same mean. The same median, because if we get the median value, it's 10 plus 0 is 10 divided by 2 is 5. And the mode is a 0 and a 10, because again they have 2 values. Okay, so we're going to study first these cases. If we just gave the mean as a value of how the students had done in the exam, the first class you could suppose that all the classes, the 3 classes, had students that were around 5. Okay, that scored around 5. That's true in the first case. It's more or less true in the second case, fairly true. But in the third case, where we have extreme values, that's not true. Okay, you have the same mean, even the same median, but you have students with a very low score and students with a very high score. So that lets you see that even though we have the same mean and median in the 3 cases, which we might have thought that they were the same case or similar cases, that's not true. These 2 are similar, but that one is not. So it's not enough to calculate the mean, and even not sometimes the median. The mean is a useful variable when all the values are more or less equally distributed around the mean. So there's the same amount of high values and low values. Okay. I have drawn here, it is not a table of frequency, it's a graph, just so that you see that they're totally different cases. the same number of values on one side or the other, it does reflect more or less the center value, but as long as we put more values on one side than the other, the scale is not correct or not stable, and values with of a high number are more important than values with a low number. I will see it right now. It's not the same to have one value of 1,000 than two values of 100 or 10 values of 100. Okay. So we're going to look at the third case, which I think might clear things up a bit. We have 7 students. Okay. 2 have got a 0, 1 has got a 3, 2, the other one's got a 3, and then we have 3 students with a 10. Okay. If we calculated the mean, we might have thought it's the same case as before, a class where more or less the students are average. But this is not true. If we look at the scores, most of the class got a very low score. But just because some students got a very high score, the balance, okay, stabilized again, even though most of them were students that did fairly poorly in the exam. Okay, so the mean doesn't show. In all these cases, the mean is the same, and they're totally different cases. Okay. However, here, as I said before, the median does reflect that the values are very low. Okay, so when there's values that are peak values, that you have a lot of peak values that might modify modify the structure of my case. The mean does not reflect anything there, but the median does. Okay, the problem of the median is that it's very easy to calculate if you have just a few numbers, but if we have a population with a lot of values, it's very difficult to calculate. Okay, and then the mode here does give you a sense that we have a lot of values with a very high score. So in this case, given the 3 variables, we get the idea that there's a lot, with the median, there's a lot of, the center value is fairly low, that there's a lot of values that are have a high score, and that's why the mean is centered. Okay, so I hope to have shown that if the mean is not enough to reflect how a population works. But sometimes we need the median, sometimes we need the mode, sometimes we need the 3 of them. And the more variables we give, the more we get an idea of how our population works, and how if there's a lot of peak values, if it's evenly distributed, or if there's a lot of low values. Okay.